What is up, guys? This is Our Anatomy here, and today we're going to be talking about what if the Earth were flat from the start. Now, don't even get me started about Earth being flat this entire time. This ain't the video for that. Let me say this. Let's say that you don't believe the satellite images of Earth and you think that Earth is actually flat. Then explain to me, how can you fly from one place to the same place if you flew in a straight line? Why is it that your weight is practically constant no matter where you are on the surface of Earth? Exactly. For that to be the case, Earth has to be a sphere, or sphere-ish. Anyways, enough of my rant. Let's start this video. Let's imagine Earth were flat. What would happen? And what would it be like? Well, let's assume Earth's gravity is still the same, so 9.8 meters per second squared. Now, if you can see here, this is the side view of Earth, if it was flat. The angle is changing as you move, and the angle there to the center of mass, which is directly in the center of the flat Earth, because by symmetry, the center of mass is in the center. And it's uniformly even around the entire flat Earth, so center of mass is going to be in the center. That's where the gravity is going to be pulled to. So, if you stand right above the center of mass, gravity is pulling you straight down. As you move to the right or to the left, you see that the gravity angle is changing. Now, what is this almost like? This is like you going up a steeper and steeper hill. So why does it seem like that? Well, just look at this hill. If you're on the ground, gravity is pulling straight down. Well, actually, no matter where you are on the hill, gravity is always going to be pointing straight down, because you see, like on Earth, gravity pulls down to the center of mass of Earth. So as you're going up, you see that the gravity is pulling down. But look at the angle of your feet. You see, as you're going up, the plane that your legs are on are getting more and more parallel to the direction of the gravity, which is straight down. You see at the very start, the direction of gravity and your feet, the plane is perpendicular. But as you go up, the plane at which your feet are on and the direction of gravity are getting more and more parallel. You can see that's almost similar to the diagram I drew before of the side view of Earth. So if you go to the edge of Earth, even though it's flat, even though the flat Earth is flat, if you go to the edge, it's going to be like you're climbing a steeper and steeper hill, because the gravity is going to be pulling on you at an angle. So you're going to be kind of leaning forward so you won't fall back, which is really, really cool. Now let's see over here. Fg is equal to g, gravitational constant, mass of Earth, mass of you, all divided by the radius of the planet squared. This stays the same on, well, the sphere Earth theory, aka theory, whatever. It stays the same because your mass stays the same, mass of Earth stays the same, and no matter where you are on Earth, the radius between you and the center of mass is always the same. So Fg is always going to be equal to 9.8. But on the flat Earth theory, as you can see, as you move, you are changing the radius, because as you move away, you're moving farther from the radius. It's not a sphere, remember, so you're moving away. So the force of gravity on you will change. So that's another different thing. You will experience, lighter weight, because if you increase the radius, you increase the denominator, and the force of gravity will get smaller. Now, another cool thing, doesn't really have to do with what you will experience, but if it's a disk, then your rotational inertia is going to be equal to half of the mass of Earth times the radius of Earth squared. But if it's a solid sphere, then the rotational inertia is going to be equal to 2/5 mr squared. I mean, it's not really going to change anything much for us, but just a little cool fact. Now here's a really cool question. Will you fall off if you reach the edge of Earth? No, you will not. It'd be like a normal Earth when you get to the edge, because once you get to the edge, well, you're just going to be standing on the edge, and the edge is basically rotating, so you're going to feel like nothing's really happening. Like right now, you on Earth, right now, just sitting down or standing up on Earth, and Earth is rotating, you don't feel really anything. That's what you will feel when you're on the edge. Getting to the edge, though, is very difficult, because once you get to the edge, you're almost going to be 90 degrees up to the ground, because remember I said it's like you're climbing a steep hill. Now, you may have 100% day, 100% night, or normal day and nights, and it all depends on how the flat Earth is tilted to the sun. Think about it. People on the edges can choose their day and nights. They could just, oh, they want day, they just climb over the edge and go to the day side. They want night, they can climb over and go to the night side. But the one thing is, if you go over the edge, well, if you're on the edge and you want to go to the flat side, you're going to fall right to the center because, you know, gravity's pulling on you on an angle, so it's going to keep pulling on you until you reach the center. So you're going to die if you get off the edge. So yeah, that's not good. And so no, water won't really like pour off the edge like a waterfall. Every water and weather would pile up to the center because that's where everything wants to be around, you know, because that's where the center of mass is. And it's not physically possible for this flat earth theory because the forces on the edge are far too great for rock to handle, so it will collapse into a spherical shape. That's just how physics works. But why is our solar system flat? That's a very good question. It's because it's not one object. It's billions of things rotating independently around a supermassive black hole in the center. That's different than this flat earth theory. The flat earth theory is about one object, so it cannot be flat.